Yeah, you are welcome to today's class. Today we'll be looking at motion of connected bodies using an inclined plane. Mass M1 and mass M2 are connected bodies with an extensible string. This is a spring and this is a pulley, frictionless pulley or a movable pulley. Then here on the string we have the tension. The tension of the string will be upward, while the weight of this mass, that will be M2G, will be vertically downwards. Then the tension will always oppose the direction of the force that will keep this body at equilibrium. That will be mass M1 G sine theta. That is if you resolve along this plane. Now looking at these two bodies, if the direction of motion is downwards, we have acceleration A. We see that the mass of the body, this one is coming down. It means it is greater than this tension. Also, if this is also going, this is another tension. The tension that we have here and the tension that we have here are the same, which means that this tension also is greater than this body or this force that tends to oppose its movement. Now I want to consider when the body is moving downwards. If the direction of the movement is vertically downwards, from here we have T, which is the tension, minus M1G sine theta is equal to the resultant force, mass times acceleration. But in this case, it's going to be mass M1 multiplied by its acceleration. This is going to give us equation 1. Then looking at this, as this force is coming downward, it means that this weight is greater than the tension. That will be M2G minus tension is equal to M2A, the resultant force. This is equation 2. Now, our aim is to determine the acceleration of the motion that combines the two bodies together. In order to determine, we have to solve these two equations simultaneously. Let's add the two equations. You can say equation 1 plus equation 2. By doing that, tension will cancel tension. So we now have M2G minus M1G sine theta is equal to M2A plus M1A. If you look at this, G, the acceleration due to gravity, is common. We can factorize it. We have M2 minus M1 sine theta. We close the bracket, equals to, if you look at these two, also acceleration is common. That would be M2 plus M1. We close the bracket. So in order to get our acceleration, we have to divide both sides by M2 plus M1. Acceleration will now be G multiplied by M2 minus M1 sine theta divided by M2 plus M1. So with this, we can calculate the acceleration of the body. We call this equation 3. Equation 3 can be used to determine the acceleration of the body when this body is moving downward. Now let's see when the coefficient of static friction between the body of mass M1 and the plane is not equal to 0. When the coefficient of static friction is not equal to 0, it means that there is coefficient of static friction and frictional force is acting on the body. So if the direction of the motion is still this direction, that is vertically downwards, it means that the frictional force will oppose the movement. We have the frictional force here. Now let's calculate, or let's see how we can determine its acceleration. So if the direction is moving this way, it shows that this tension is greater than the two forces that's keeping it at equilibrium here. It means the tension will be applied to this to overcome these two forces. We now have tension minus m1g sine theta plus the frictional force is equal to mass times acceleration, that is m1 multiplied by the acceleration. This is equation 1. This is equation 1. It's equation 1. Now, in order to determine equation 2, we are still going to look at the weight and the tension. The direction of motion is downwards. It means that the weight is greater than the tension, which means that m2g minus the tension is equal to m2a. This is equation 2. Now, solving equations 2 and 1 simultaneously, we can just add. We can say equation 2 plus equation 1. If you do that, the tension will be cancelled. We have m2g minus m1g sine theta plus the frictional force equals to m2a plus m1a. Let's remove the bracket. We have m2g minus m1g sine theta minus the frictional force equals to m2a plus m1a. And we can factorize the equation. Acceleration due to gravity is common, mg. We can factorize the m1 sine theta minus the frictional force is equal to, acceleration is also common here, m2 plus m1. Then from our frictional force, which is coefficient of static friction multiplied by normal reaction, we can now have it g into m2 minus m1 sine theta. If you now substitute the frictional force, we are going to have minus coefficient of static friction times normal reaction equals acceleration multiplied by m1 plus m2. Now let's make our acceleration subject of the formula. We can now divide both sides by m2 plus m1. Now have acceleration equals g into m2 minus m1 sine theta minus coefficient of static friction times normal reaction over m2 plus m1. So we can call this equation 4. Equation 4. This is how we can determine the acceleration when the coefficient of static friction is not equal to 0. Now we want to look at when this body is at equilibrium, because if you look at equation 4, you see that there is normal reaction in this equation 4. How can we remove this normal reaction and put something else? Because before we can have normal reaction, the body M1 has to be in equilibrium. Now, so let's look at this. If you are having this body at equilibrium, so that there is going to be normal reaction. The normal reaction that will be perpendicular to the plane, the slopy plane. Then we have the weight of the body, M1g. Then we have to trace the sense of the reaction. That will give us M1g cos theta. That is, if you resolve perpendicularly with the plane, this is what we are going to have. At equilibrium, normal reaction is equal to M1g cos theta. Let's substitute the normal reaction in equation 4. Substituting normal reaction, in equation 4. Equation 4 is acceleration equals acceleration due to gravity m2 minus m1 sine theta minus coefficient of static friction times normal reaction over m2 plus m1. So we are going to substitute the normal reaction into this. Therefore, we have acceleration equals acceleration due to gravity times m2 minus m1 sine theta minus coefficient of static friction multiplied by m1g cos theta divided by m2 plus m1. So this is equation 5, which can be used to determine the acceleration of the body when the coefficient of static friction is not equal to 0. If you have the normal reaction, we can calculate the normal reaction by considering that the body, the mass m1, which is on the plane, the slopy plane, is at equilibrium. Then from there we can determine the normal reaction and substitute into this equation to determine the acceleration of the